Good morning. Welcome to System Analysis and Design, March 3rd. Here are the plans for today to kind of finalize that last case study having to do with data diagrams and jump into some of the main concepts here for object-oriented analysis. It's going to make good connection to anyone doing Java. Hey, you got a haircut there, Mr. Matheny. Looking handsome. Not quite as short as mine, though. A few more years. Don't even have to worry about the top there. So down here in section 5, we finished we're finishing up the data flow design, and let's check the case study. Any questions about those, the other decision tree, logical rules, and build a decision table? Any questions about that? Let me get the book up here. I didn't specify what logical rules. Did they specify one in the? Let's see if they specified one in the actual case study. Let's see what they had there. And I'll bring up the online copy of the book here. So down there was session 5. Let's check our to-do list. See if they mentioned that there. Case tools. They didn't say that there. How about the inbox? Logical model. Context diagram. 4 processes. So they mentioned the 4 processes. Manage courses, register students. And we did some of those on our own. And case tools, we'll skip the case tools part. Is there a decision tree here? This implies something about a decision tree. So we could use this data to decide our decision tree. So based on this information, basically build a decision tree. And let me bring up the examples in the book. I mentioned, I think in the case study, there's some examples. Page 175. And the book does kind of breeze through some of this stuff. And so a lot of this is more giving you some quick examples of it. 175 doesn't take me to the right page. I think I lied to you there. Let's see, it's chapter 5. Looking for a decision tree. There's, yeah, 224, 225 have your little decision trees. So that's not 175, that's 224. I should fix that. So we have a decision tree. Let me bring up page 224, not 175. And we could do that, you could do that just in I suppose, an Excel spreadsheet with different columns there. That wouldn't be too hard. And if I jump down to 224, here's an example of a decision tree. So we're not looking at something terribly complex, but you can see as you have more decisions to make, you're basically doing every combination of however many decisions there are going to be the bits in your decision tree here. And so 3 decisions will leave 8 possibilities, and then you have X's what decisions you're making. So if we look at this kind of table, how about we just do a quick little spreadsheet with that one. So I'll make a list of my decisions, and this is supposed to be a spreadsheet. I guess I brought it over too quick. Here it comes. And our decision tree, based on the information we have here. And let's see here. We have eligible for a discount. It looks like the decision we're making. So eligible for a discount is the decision, and then we have to look at their inputs. So let's looking at an example from, did I lose my book page? I think I lost my book page. I dragged a window over here. Let's get back to my book page. I should still be signed in. Oh man, kicked me out. And page 225. Okay, back to the book page here. Try not to wipe out the page again. Here's what we're trying to make, a decision tree like this. And we have, as our result, will be discount. So back to our spreadsheet. Down here somewhere will be, they receive the discount. And the data that goes into our decision has to do with some status here. They specify 3 specific rules. Enroll for a second course. Okay. Oh, and there's actually 2 discount rates. So we'll just have that A and B in our discount. So there's a discount, and then it's a discount yes or no, and then discount rate A or B. So enrolled for a second course would be one of our statuses. So it would be second course. So there's going to be a yes or no in the discount. And then it would be A or B discount. So we could almost apply that in our result as 0AB, or we could make it yes, no with an X, and then if it's A or B. So let's, I'm going to try the simple way. I'm just going to have nothing there if they don't get a discount, or maybe an X, and then A or B if they do get a discount. So the first criteria, and let's see, we're supposed to have, we better have a nice title here. We have our verify order process. We'll call this calculate discount process. This was case 5 decision tree. So the second course, if they do have a second course, well, we're going to have to put all our possibilities here and then lay out our little grid. So go back to our email. So second course, discount rate A, keep that in mind. Employed by client. Okay, so that's another status, employed by client. Now we have an additional criteria waived by Amy. So that would apply discount B. So we'll call discount B waiver. Okay, so the choice we can have is a yes or no if they have a discount, and if they do, it's an A or B. So now we have to give all the combinations of those to properly represent all the possible decisions. So now this is just a mathematical thing, so we'll use n's and y's for our combinations. You can think of those as yeses or no, or zeros and ones in a binary possibility. So if we want to consider this to be our least significant bit, let's see how they did it in theirs. We'll try to copy theirs. So they started with all y's and then ended with n's. I guess we'll do that just to be consistent. So I'm going to be lazy here and go all the way out, and let's get all 8 of them in here. And I think I can give them 4, 5, 6, 7, 8, give them a similar width, see if it behaves like Excel. Yes, it does. Okay, if I look at my table here, you can see that first bit changes after the second. So there's a pattern going here. So let's get that same pattern, kind of a binary values here, and then y, and n, copy, paste, yn. Hey, let's see if I drag it. We'll do yn. Look at that. So there's all my possible combinations, and I can zoom in on that. Now we have to then just fill in so we can in code understand what has to happen and very carefully, systematically cover all the possibilities. And that's the point of this decision table. Make sure that you have covered and don't say, well, I'm not sure what my code does when I have this status. Well, you can actually write code that has this kind of thing in your data and make decisions based on a data table that looks very much like this. But that's up to the developer actually how they do their code. You could have your code that is a huge if-then statement that you can't tell at all if it actually matches your decision table. So now, how do we fill in our decision table? Well, let's see here. From our data here, eligible for discount when they enroll for a second course, so that's discount rate A. So let's put A if they've enrolled for a second course. So that would be here A, and A. And it doesn't tell us which is the better discount, does it? Do they? I'm assuming A is better. They don't say though. So we'll assume anyone is employed by one of SCR's corporate clients eligible for a discount. We'll call that B. So employed, they get a discount of rate B.
Wouldn't it be Y instead of A? Or I don't get why
Just because A will represent, yes, they do get a discount. They're eligible for A if they have a second course. They are eligible for B. And you know what? Since they'll be eligible for both, I'm going to put B here. So let's eligible for A. And let's see, if they're employed, they are also eligible for B. So wherever we see a Y, wherever we see a Y in the employed by client, they're also eligible for B. Somehow I have an extra line in there. And with nothing in there, I'm thinking that will represent a no. Now in their table, what did they do? They did a X's and had multiple statuses down here. So I'm doing a little different than here. I'm thinking, no, I'd rather just see what discount they're eligible for here. If there's something in there, that means yes, they're eligible for that. And if they do get a discount B waiver, they are also eligible for B. So here I'll also put a B here. And a B, oops, why didn't it show up? I did a Control B instead of a Shift B. Turn off that. Discount B waiver there, B, they're already there. Also discount B. Now the question is, these that are eligible for A or B, I guess, do they tell me which is better? I'm assuming I'd get the better discount. So I guess based on what they say here, they don't tell me which is the better discount. Second course discount, employee discount, or if B has been waivered. So I could leave these blanks, or to indicate I have analyzed, I could put a dash there to mean there's no discount. I'm happy to leave it simple. So there's our calculate discount decision table. Now you could also, instead of doing A or B here, have an X and call it discount A, and have X's where they do get discount A, and then have a separate line discount B, and then the actual discount we could just say is the better of the A or B. How it's stated here doesn't make it clear which rate they get if they're eligible for both. Oh, it says here they can receive one or more discounts. So it's not either, it's they can get both. So I guess we could put decision of here we get A and B. If I actually want the final decision, here we get just A, here we get just B. And here we get no discount. So I wasn't paying attention. At the beginning it said you can receive one or more. So it's not an either or. So a decision tree like this, I did it in Excel because it's easy. You could just as well done it in a table in Word or any word processing program. But this is the kind of thing we're looking for. The nice thing about a word processing program is then you can actually have the text of the description of how you're making these decisions. You could actually have these lines in here explaining this is a decision tree based on the communication given from Jesse, such and such a date. Here's the text of the email telling me, this is what the decision was. Based on that, here's the decision tree. So a document would let you carefully list, here's why we calculated this table. And if anyone has a question about it, they can always say, well, let's see what she wrote us again. Yeah, that's our correct table based on what she wrote. But there's your decision table. And in the assignment, decision tree is listed on 227. That's a little harder to draw. Based on the above rules. Oh, I just said here, create a list of logical rules. And that was listed on page, actually, we even, I don't think we even have a list of logical rules. I think I'll throw out that part. Let me fix this here. We'll just, since we did this in class here, let's just say, instead of, that was page 224, I'll just say use the email to create a decision table. That's what we just did. Actually, to just build a decision table. And this was on page 224, not page 175. And how about we skip the decision tree part because we want to move on to object-oriented. You happy with that? Will that work? Okay, so you can use PowerPoint. Basically, we've done that decision table based on the email. So maybe put a little comments around that about this is, you know, kind of MLA style. This is your derivation of a decision table based on the communication from Jesse regarding course fee discounts. So I always want to have some description, not just, hey, here's a table for you. Have a description kind of explaining where you got the information from. And then it's nicely packaged. Okay, any questions about that? And have we made any mistakes here? It's easy enough to do that, but you see how you put in the data that affects your decision and then all possible combinations of that data. 3 pieces of data means 8 combinations, and then based on those you come up with what your final decision would be in processing that.
How did you know off the top of your head how many columns?
Because I have three decisions or 3 yes or no questions affecting my decision. I know that there's like I can treat like 3 bits of a binary number, and I know a 3-bit binary number goes out 8 places. And why? Half of those, basically you can kind of see the pattern here. You have to basically get all combinations. Now I could be counting binary. Does this count binary? If I count from here, treating ends as zeros, I'll have 0. If this is my least significant bit, 1, 2, 3, 4, 5. So it's kind of, you look at it as zeros and ones, you can see it's a binary number counting up. That's just a way to confirm, yes, I have all the possibilities. So the number here is always going to be 2 to the n, where n is how many things affect your decision. This is a very simplified decision table. There's going to be some decisions that will have more than one possibility. Then it increases your whole decision table size. I'm not sure how often I would be using a decision table if it got terribly complex. I think people looking at it might just be confused. What does this represent? I don't have a clue. If it's clear enough, there is actually a way you can actually build this table in your data, in your actual code, and have it affect how, and basically build what your program does based on information in a data table. And in some programming styles, it's called a state tree or a state diagram. And you can actually confirm and make a program that behaves based on information in a data table. What I'm thinking of might be like a menu structure. You can just have the data here representing whether or not they've clicked a particular button, and then when you receive button events in the user interface, you just go to your table and say, okay, based on what button has been pressed, I go and do this. And the decision is an actual name of a function that runs based on this combination of inputs. And someone can come to the program, all they have to do to change the program, they don't have to dig down to this code, they just say, oh, I make my decisions differently now, and change that, and now my program behaves differently. Microcontrollers are programmed like this often because they have various inputs from the buttons at the, say it's a microcontroller for a car engine. based on certain inputs, yes or no, the brake is pressed, the turning signal's on, the clutch is in a particular position. You know exactly what needs to happen, and you can simply program your engine microcontroller with a kind of decision table. All right, let's move on then to a different kind of diagram. We're looking now at modeling object-oriented code, not data flow. And we're going to be visiting some concepts in coding, but first take a look at some unified modeling that they're going to be doing here. We've talked about this before here. I think they start with objects first here. Here we go. We're going to look at this first, having to do with modeling, not data flow, although it looks a lot like data flow in some of our drawings. What we're modeling is the objects that we're planning to use when building a system and actually building the code. So instead of thinking, okay, here's how data flows between processes, getting me to think about what's happening with data within my system, now we kind of switch gears and think, okay, now in order to make my data processes or make those processes that are handling data work properly, I now want to think about how am I going to behave, how my system is going to represent the processes and the objects within my code. So jumping to objects now in the very general sense, not specific code for our particular case study, but just thinking of object-oriented analysis, and now we're leaving DFDs, and now we're treating objects, thinking of both the data and the processes that will now deal with that data flowing between the processes in my system, or how a process actually handles data. So the terminology for object-oriented design and just the concepts here have to do with objects that have attributes. That's probably the easiest part of objects, is they have attributes. When I define what I like to define is like the button control on a user interface. It has a color, it has a size, it has a caption. Those are the attributes of a graphical object. Then as I need things to happen, like when I click this button, something has to happen. I say hello world. Well, I send a message to my main window to get that hello world message displayed on my user interface. So messages are a little more complex, and methods are very similar. A message is, hey object, do something with the data I've already given you. A method may be, here's the hello world string, I want you to go display it, or I want you to check to see whether you run into the wall or another object and blow up if you have, because that's how my particular user interface works. So objects, it's an abstract term. We haven't decided what objects we need in our system yet, but we're going to think about, okay, once we do have an idea of what objects and what the system needs to do, think about the objects and attach attributes to them. And you know what? This is a common way of programming. Let's make up a diagramming scheme to go along with this. And that's where we get to the UML. And let's jump ahead to what the UML diagram would look like here. They have one somewhere. So they show, here's the relationship diagram. This is kind of a very loose relationship diagram of the relationship between employees, instructors, and staff, the people, and then we have data here. They have a more strict UML modeling between objects. I'm going to skip over the use case at this point. I'm going to jump ahead to, do they give us some UML modeling of, I'm looking for the actual UML modeling for code. Look at that. They don't actually give you a UML model. I thought they gave us one here. They gave us a very loose one. Right here. But there is more detailed UML modeling systems. And let me look at one here. I've put a couple links up here in chapter 6 here. And let me look at the one I was looking at this morning here. Here's a nice, well, actually IBM provides a little simpler one. This goes into a lot of details explaining UML presentation of objects. Here's an IBM couple examples of objects and their relationships in the class diagram. And let's just jump down to a diagram here. Here's an example of a class diagram where you have a flight class and the attributes in it are it's the flight number, the departure time, and the type of data that is, and the duration of that flight. Attributes here in this section, the name at the top, and then methods also describing the parameters that each method needs. It takes an integer for specifying the flight delay, and it returns a date. So this is a method that actually has a value return. This is another one, has no parameters. It will get your arrival time in the date format. So date includes day and time. And some examples here, we'll jump down to two objects, actually three objects. The main class, bank account, has to do with an owner and a balance. The owner of the account can call the method, deposit some money, withdraw, or whether withdrawal has been made, and italics means something different. Now the arrows between these in the proper UML represents this is a child object, or this object inherits the characteristics, attributes, and methods of a bank account object. And that's where we get a little more complex, more abstract idea of inheritance from a main class. And this is all, if you've done proper UML diagramming your code, this shows checking account is a subclass, inherits the standard attributes and methods of a bank account with these additional attributes and methods that a checking account only has. So a savings account doesn't have insufficient funds fee, but every account, since they inherit from bank accounts, all have an owner and a balance. So this is a nice example from IBM, just showing how UML has more details describing relationships between objects. In the book, it gives you this very foggy, not quite, none of the methods and attributes mentioned. We're going to be getting into more details in a future chapter. But at this point, they're introducing object relationships just to show you that gets closer to the code level of relationships between my planned code.
So when you do this as well as the DFD and
Yeah.
Decision tree, and
Yeah.
you do everything?
Well, depending on what your team likes to use, they may do the data flow diagrams and skip some of these others. This book is introducing the common tools that many people use, but I doubt that wherever you go, they're going to be using all of them. The UML, from my research on UML, you find a lot more resources on UML than I do on data flow diagrams. Like the Glyphy program, it has UML, all sorts of UML symbols, but I couldn't find the gain source in there. I only found gain Sarsen and Visio. But every program has UML. So it made me think that the UML is and the class diagrams are more commonly used. But I won't really know for sure until I come to find a job and see what they're using on that particular team. And you can buy software packages that may emphasize one or the other and say, hey, based on this UML diagrams, we can actually generate your code templates. And if people want, if they're writing a system that they find that that's a great way for them to diagram that, they'll use that software and do UML all over the place. Maybe never even touch something like this. But if you use something like this, say you're working on a system and you're trying to have everyone on the same page regarding, hey, here's how people interact with our system, and you start doing a use case, if anyone has taken any college courses, they will have covered in system analysis. Yeah, this is one way to, a very common way of describing interaction with our system, and that's our use case. Representing interactions in multiple ways of different external entities with our system. And the thing about the use case is you can have a description of it, and it's a specific event or activity in our system that's important for its behavior. And do they have a full use case shown here? A full use case shows, here we go, here's an example of a use case describing a particular activity, how to handle work. So it describes how a customer comes, requests from top down, generally how you read these, and left to right, requests a service, something happens in the system that creates a work order, and as it, these aren't necessarily data flow, see how these are more initiating activity. These are more verbs here now on the arrows. Where then along the process, after our service writer decides to say, yes, that's the work we're going to do, here's the estimate of it, then the mechanic performs the work, being given some information from his system about what he needs to be working on, his schedule of work. He gets a notification or report that morning of what work he needs to do, performs the work, signs the invoice, does his test, verifies the tests are done, verifies how long he spent on it, and then service writer gets the invoice. Now notice this use case doesn't show the end of it, how the customer then pays and they verify his credit card. That's another little process that would be another use case. But this is a way to diagram interaction with our system that's in the minnow box. Similar to our data flow diagrams, we're seeing these external entities interacting. Here, we're not so much doing the strict data flow, but describing here's what happens when those sequence of events occur. This kind of diagram may help you catch anything missing, maybe you didn't see happening in a data flow diagram of, oh, the service writer, he needs to check on the invoice. Oh yeah, in our data flow, we don't have that. This might trigger someone to say, oh yeah, there is some data that the service writer needs to see. There's a process that needs to do a confirm invoice. That having talked through a use case, they'll get the light bulb here. Oh yeah, I need to have this happen in my code. That wasn't happening. They talk about a class diagram. Here's another use case showing basically the what are we doing? Create a bus route. Just create a school bus route. So this would be some sub-process of a bus scheduling system where we've got a student enrolled in the school. that initiates a, hey, I better make sure my route covers at home sometime before school starts so I can make it. A dispatcher sees that that needs to happen. Looks like we have a manual process here of the dispatcher somehow inputting the system that generates some kind of a route, looking at the efficiency, and I'm sure this can be a very complex process based on one-way roads and time of day and roads that they don't want the bus to travel on because it's too narrow or too many hills, especially in Dubuque. You don't want to drive that hill if you can possibly avoid it, especially on days like today. The dispatcher, and this is showing that somehow the dispatcher creates the staffing plan, maybe finds drivers that are able to drive that route. Something in the system is doing these three processes and then telling the driver, here's your new route. Notice the lines are verbs here, and the notify, we know that that involves some kind of a probably a little route map for the driver. But just again, this is just another way, another possible tool in your toolbox of describing your system behavior so everyone's on the same page, and using, as you develop these use case diagrams, put them in your documentation as people want to learn, either to be on your team to help develop it, or your customer to know how your system actually works. So developing these, now it's going to be tricky as you change your design and do your prototypes and adjust your design. You'll want to be sure you come back to here. If you are indeed using this in your documentation, make sure it matches how your system is finally designed. You may have additional processes or additional entities, and it may not quite work as you originally designed it. The idea of having all these designs is you finalize them, and then you go write your code, and the writing of the code gets so much easier because you have clearly talked about what has to happen instead of, oh, let's go grind out code and stumble all over the place and then finally realize, oh, we can't do that. We're missing some information. Here's some cardinality is something that it's a little more confusing until you get into the exact details of a system. Knowing how things relate to each other gets closer to, in my mind, if I have a database scheme somewhere in my system, this will help me develop the database relating items and information in my database. So the 0 to many notations are included in UML because there's often a strong database connection when you actually have a working system. So if you don't have a system that needs that kind of thing, you might forego the cardinality issue. But just to go over the cardinality, there is in UML a way to show, even if I'm not dealing with a database per se, I am using the similar terminology of items in my system or external entities for every employee. There may be 0 to many payroll deductions. Now, if that's in the database, that's fine, but somewhere I need to show that, hey, there may be more than one payroll deduction. So the cardinality just makes it clear what we're talking about when we're referring to employees and spouses, 0 to 1. Office manager, he better have a sales office if we're dealing with maybe laying out the office diagram or doing an architectural plan. Hey, if we have an office manager, make sure that that contains a sales office. And an order, you know you have to have at least one item ordered, or you don't have an order, but there can be more than one item in the orders. So as you do UML, they'll start looking like this. Here's the details of a full UML that shows different objects in our system. In these cases where the objects are people and orders, the attributes aren't listed. there's going to be a whole list of attributes. Right now they just show a section containing attributes and showing cardinality between how our concepts of how our system is going to work. Now, depending on who's developing your code, you may have a different arrangement of your objects, but anyone that looks at this will have an understanding. This is UML diagramming our plan to implement our system, keeping track of these various objects, attributes, methods. So this is the overhead view, the view of the forest for objects and attributes and how they connect. And way back at the beginning, they showed you the specifics. Oops, wrong direction. Turn the page here. Let's see if they give the specifics. You jump back to the beginning of the chapter where they were looking at all the specifics of those objects. See how the attributes, there's going to be details of attributes. This section, if you zoom in on it, will have many attributes. So kind of a quick view into the objects design of a system, and then building up, going around use cases, and then coming back to objects here at the end after talking about cardinality. Here now, well, we'll come back to sequence diagrams. Where did what page was I on when I saw that main point? All right. Was that at the bottom of that page? There it is. So they talked about objects showing details, use cases, and class diagram, and then coming back to the class diagrams. Oh, after cardinality, then putting it all together. The objects with their attributes, methods, cardinality between objects, with use cases thrown kind of in the middle, just to confuse you, I suppose. Now, coming out to the sequence diagrams. We talked about this, was way back in chapter 4. We just touched on it. This, I'd say the sequence diagram, to me, kind of fits better right with use case diagrams, where from top to bottom in a use case, you go through what happens with your system. Here in a sequence diagram, you're showing the actual interaction between those classes that you're starting to define, and actually what happens between classes as sequence of events run. So we have, not sure what the lifeline, the lifeline is the life of that particular class. Sometimes you could think of this as a variable you're using in a program, where for a while my variable is used to calculate the angle based on where my mouse is on the page, the angle from me. And using those variables, I figure out where to aim the laser, and then I'm done with the variables. So it's the lifetime of those variables goes away. I end that function, and that variable was a local variable. That would be the lifetime of a variable. Now the lifetime of a class would be, I'm starting a function that uses class 1 and class 2. I create a new class, an instance of it, maybe read its data from a database or table, and as I'm dealing with it and another class, there's messages that they use. Maybe when class 1 gets a particular method, or yeah, when it runs a particular method, it sends a message to class 2, I need information from you. It gets the information and does some processing. So this is just a way to show the lifetime of variables as my program is running. And the rules about sequence diagram is the dashed line represents the object is able to interact with other objects. Usually it's because you've defined or made an instance of that particular class, and now we're doing something with it. And when I'm done with that, I have a big X there. If I have objects that are sending messages to one another, then we include the little arrows with a label on what that message is. Now this isn't going to make a whole lot of sense if you haven't done a lot of programming, or programming is still a little foggy in your mind. So don't worry too much about writing code and knowing exactly what goes on in the code. Just be able to recognize a sequence diagram. When I see something like this, I'll know there's some variable, an object called student, that is needed during this particular processing in a sequence diagram. And it interacts with the manager object, and then some kind of a schedule variable, and then more code is written. They're running processes, doing algorithms, and at some point there's a notification between the student and the manager object. Then the student interacts more with the manager object. Oh, and suddenly a registration record object is needed for a while in my sequence going top to bottom in time. The registration record isn't needed for very long. We throw it away after updating a record perhaps in the database. We're done with that, but the registration information we know is stored somewhere. But in our active code, we don't need to worry about what happened in memory or what's going on in that object. We're done with it at this point in time in this particular sequence. So if this is the add new student, in this particular way of performing that task, this code designer, as through discussion, has kind of conceived this kind of thing happening. Still hasn't written any code yet, though, but he's getting closer to, here's what I'm expecting to happen in the code. I hit these classes of variables, make these kind of things happen between them, and then my student has been registered is the last thing that happens, and then I'm done. No more documentation for that particular activity of adding a new student. State transition diagrams, again, another way of showing what can happen in a system. And you see there's all these kind of diagrams. You're probably not going to be using them all. The main thing is to be familiar. When I see something like that, I'm not completely foggy what they're talking about. Well, let's see if we can understand what this is doing. And you could probably see how if I had a use case or a sequence diagram, this is kind of just another way of looking at it. Let's zoom in a little bit here. Here's the initiation of a sequence, left to right. An activity now. We make a new account. And I'm not sure what happens in this box new. I guess each box here is representing the state of what? The state of the system, I guess, in a particular, or a state of a particular process within the system. So the state here is representing the account state, right? Bank account state is new. The owner makes the first deposit. Now the state of the bank account is active. You think existing would be implied by new, so I'm not sure why they put existing there. I think active is the important word there. And the state of active may depend on how much time has passed between here and a deposit. But we're not thinking about that. We're just thinking about the state that an account can be in. Now from here, doesn't show an arrow. What happens for it to be frozen? Well, I have some assets attached to it, like they owe a bill or there's a lien on a car. that our account is frozen until those assets are paid for, or the account balance is increased to cover them, so assets are then released. So it's not clear to me reading through this, how do I get from active to frozen, and what does frozen mean? But the diagram is a point of discussion among designers of, okay, I can have these states of accounts. What happens to get out of a state? And this is where the coder would say, okay, I need to write the code that figures out, can we change a account from frozen to active? Now, let's look at the other lines. If the bank closes the account, the state goes from active to closed. So I would think that they're missing the arrow should be going this direction. Or if the customer closes the account, it then becomes closed. Now, thinking about this process, could there be another line? Could you ever go from closed to active? Or is this a one-way thing?
I mean,
Could you reactivate an account?
an account number with it and everything like that. They probably would just give you a whole new one. Right?
Yeah, yeah.
So
And that's the way banks work now. I'm thinking if I were writing the code, like I do with like users in the Google Apps email, I'll inactivate a student user first, and in Moodle as well. I'll inactivate them. Then, in case they do re-enroll, I don't have to re-enter and have a new student ID. I can just reactivate. So instead of closed, I might make it an inactive or a former. So maybe there's hooks that if they do come reapply, because we'll want to get our customers back. I wouldn't want to throw, and I'll bet you government rules do not allow us to close and throw the information away. That close does not mean it's out of our system. Close means something has to happen either to reactivate it, or we may be able to use that information. If they apply it for a new account, we may be able to clone the information from the old account, seeing that they had a former account. So we have their name, address, and we can always get at the previous information in case we decide, we really don't want to let that customer back because the status of their closed account is because they had a huge debt and they didn't pay it and a horrible credit rating. We don't want them as a customer. And that may be a decision that's determined here when we're saying what can happen to make an account new. So again, just another way of looking at thinking through how to make the system work. You have your tools a variety of ways. This is your state diagram. And I will bet you there's a whole books of theories of what diagram is best used for certain types of programs. Like if you're deciding the controller for a microwave, it's on or it's off, or it's at a particular power level. Maybe describing the code for a controller of something like that, a state diagram would be a great place to start. And then you go to a use case, thinking of the simple interaction with the system. Going to a class diagram, maybe it's such a simple system you don't need all those class diagrams. Where a state, you have simple activity, and turning a switch on or off doesn't need to involve math attributes and methods. As you get a more intelligent controller of your microwave, keeping track of what meals you've cooked, maybe even interacting with your refrigerator, knowing your inventory, what's in there, your microwave could do a lot more intelligent things. That's when you might get something more complex. So depending on the level of your programming, and of course the preference of the people on your team, and what's most helpful to them, you decide on what diagrams to use. Similar to the sequence diagram, your activity diagram shows you just the activities that happen as they go through their particular I'd say this looks a lot, to me, conceptually, a lot like the use case, where here's what's happening as I go through the process and making decisions along the way of what happens. So there's a lot of things discussed there, and there's ways to use this kind of stuff to finally get into how we're going to plan to actually do the final code, the programming part. But I think I'll stop there and go over the plans for the midterm on Thursday. The plan is material from chapters 1 to 5, some from chapter 6, the concepts from chapter 6, understanding the use case. And let's take a look at some of that here. Let's see if we can look at the review quiz. I want to just jump to the, I think I have a matching one there. Let's take a look at your matching. See if we have any trouble with this guy. Let's see if we have enough understanding of object modeling and use case. Hannah, what do you think? The lines show relationship between classes, have labels, define the action that relates to classes. And this lines show relationships between classes. And you can look in the chapter 6 pages. One, call a friend.
Class diagram.
Yeah, I think it's class diagram. It just shows the relationships between the different classes. Okay, Micah, requires many types of diagrams to represent the proposed system. So this would be a broader term, just describing what you use to do many diagrams. So something broad like case tools, object modeling, UML, those would all be very broad terms. So I'm thinking it's probably one of these three. The others are more detailed parts of that. Case tools, give it a try. I'm thinking UML, but we'll see if they have another one that's more broad. So there's going to be three broad things. And there may be one more close to UML, but I think UML is also a possibility there. So we'll put case tools for now. What do you think, Hannah? Shows objects and how they interact to perform business functions and transactions. So objects specifically. So we've got object modeling, object relationship diagram. Probably one of those two. Okay. When you identify this, you place the use case on the diagram and add the actors and show the relationships. What do you have to identify before you place the use cases and add the actors? And I think they show you this is one of the sequence of things as you develop a use case diagram. In their discussion, they probably said, do this first. Page 258. Except that's not in there.
System boundary.
260, because I was looking at 258. It said after you also develop a use case description. Oh, 260 says, yep, you have your system boundary first. Okay. That one was based on the exact reading of the book. I'm not sure that you have to do it in that order. So that was a little fuzzy question. I would say the book describes this order of things. I'm not sure you have to do it in that order. Does not want or need outside interference.
Black box.
Yes. And you also do not know what happens on inside of it. So you not only cannot interfere with it, you cannot know what's happening within it, unless the seller of the black box lets you see what's happening. Shows the order in which the actions take place and identify the outcomes. State transition talks about the condition the system is in. So I think that would come later. I think we're thinking more the activities that take place. But we'll see. You may be right.
I got some study to do.
Ensure consistency and provide common links so that once objects are described and used in one part of the design, they can reuse multiple times without further effort. This is the whole goal of object-oriented, reusable I think this is probably a better use for case tools. They help ensure consistency. Yeah. So I think then this would be UML. And I can even check the answers for you. Mainly used to support object-oriented system analysis and develop object models. Uh-oh, that could also be UML, couldn't it? Or it could be object modeling. It's hard to tell. UML or object modeling. I'll try object modeling since it's specifically object-oriented. Reading from left to right, the lines show direction and describe the action or event that causes a transition from one state to another. So this would be your state diagram, state transition. So the state it's in and then what caused it to change from one state to another. Sequence diagram, and X marks the end of this. That would be the life of a object. All right, let's see how we did. I don't know if we can we grade this or just
Grade it and it'll just
yeah.
get all the other ones wrong.
Right. All right, so we'll do next. And submit on finish, see how we did. Uh-oh. What was our choices there? So object model, it looks like I did get that wrong. So they wanted, UML supports object-oriented. Object modeling shows how they interact. So we have these two backwards. Sorry, many types of diagram, that'd be object modeling. Object-oriented, specifically UML. But otherwise, look at that, we got those right. So this will be the introduction of the Chapter 6 concepts. I remember this little matching is on the midterm, so go over that. There's a few questions from Chapter 6. Let's go ahead and review some of those. We got some time.
So pretty much it's like reviewing.
Yep.
the business.
Yep.
You said there's going to be maybe drawing a diagram or a
Data flow diagram
Yeah.
with Mark basically identifying flaws in a data flow diagram.
Could you upload some of these class videos so I might
Yeah, all these videos are all there. I'll show you where they are. And I've updated just now. I've updated your case study assignment. All you need to do is the decision table. Don't worry about the decision tree. But back to the course itself here. There is a little section there provided for you. All right, here, video lectures. And let's see if I've got the latest ones there. I've tried to keep up to date with those. Oh, looks like I didn't get the 26th. I know I did one. Let me update that with the one on the 26th. And I'm hoping the quality is improving as we practice these videos. Now that we have a little better decor in the room, and now we've got live video. I'm telling you, we're gonna be super fancy. We can start paying, charging money to take the online course. Sell them as DVDs. I get royalties. I could just retire them. When you see me doing these videos with like a beach in the background, you know I've made it. Just doing this for fun. It is actually fun. I enjoy going through this and hoping that you'll be using some of these techniques in your future successful careers. Either as the project manager, maybe the person doing the code, being there reminding them, or just suggesting, you know, I've heard about this UML stuff. How about we use some of those techniques to help us figure out this project? And a month later, the manager come around and say, you know, that project really has some real good guidance. We'd like to give you a raise and have you run this entire division.
How many credits do you think you'd have from teaching classes? You know, how many classes you've gone through?
Oh man.
You probably have like 100
Yeah.
bachelor's degrees.
There was one other link that I kind of liked here. Where did I put that back to? I think it was in chapter 6. Oh, let's forget about that. Let's go and look over some of those questions on chapter 6. Just to help you review this together, since I know I did throw some of those in there for your midterm. So I think I've set it up for these quizzes that if you take them, it remembers your best score. Reattempt. Oh, we didn't do so good. 26. Now we'll skip these. Let's see. We'll just fix the ones that we know we got wrong last time. It was, oh, it's reordered them, didn't it? There's many types of diagrams. That would be object modeling. Specific to object-oriented to develop object models would be UML. Otherwise, the others we did pretty good. Major advantage of object-oriented is that systems can save time and avoid errors by using what's important about objects to make them avoid errors. I think one of the first two. What'd you say, Hannah?
I was thinking dynamic.
Dynamic sounds like a good word, but I think they're looking for modular. Let's find out. I have to open this in a separate tab so it doesn't complain. Yes, modular. Modular meaning it's encapsulated. All the code that does that thing is only here. Dynamic sounds good, but that usually means it can change. Sometimes that's a good thing, but for coding and avoiding errors, you don't want things changing on you. You want them modularized. Here's what we do here, and it doesn't get affected by anything else happening in the system. Tells an object to perform a certain method. That's a term they use in object-oriented programming. It's a message. You send a message to objects. A group of similar objects. A class, yeah. Let's make sure I got that one right. It's not an aggregate. Aggregate sounds like a good thing of grouping. Let's see if I got this one right. I'm thinking a class is one object. Let's find out. No, it's not aggregate. So it's probably object. Yeah, a class. Okay. Represents a real person, place, event, or transaction. Again, an object. It belongs to a group or category called a class. Tasks or functions the object performs are called methods. And you're Mr. Java, so these all should be pretty familiar to you. Inheritance. We're going to make sure you do inheritance before you're done with your Java. That's a really good thing we're covering here. And it's up there after figuring out variables and branching. You want to be able to actually create classes and inherited classes. Similar to adjectives that describe a characteristic of an object, objects are similar to nouns. That would be attributes of our object. A lifeline is identified by the dashed line. Object can blank certain attributes from other objects. Inherit. Like you have an object, they showed an object, a vehicle, and then you have an automobile or a car. I think the IBM example also showed that. Well, we are done for today. Feel free to review those questions for the midterm on Thursday, and I'll have that available for anyone online as well. Okay, so did we cover what we said we were going to cover?
Homework due Thursday, or will we leave it?
For spring break, to have you work on it on spring break?
I don't know.
Would you like to? Or would you like to just have it done? The chapter 5 homework,
6.
I'm thinking I'll give you more time on chapter 6.
Okay.
Just because we're kind of hitting it early.
As long as, yeah, that's
Yeah, we'll do that. Chapter 6, we'll give you some time on, but there will be some chapter 6 questions on the midterm. So I'd highly recommend going over your e-quiz, going through the concepts in the chapter 6. But we'll work on the case study part after the break. And you're welcome to spend some time on that and get ahead if you like.